Hey y'all, in this lesson we are going to look at analyzing linear associations. By the end of this lesson we want to be able to say that I can use a line to represent the relationship between paired data. So our essential question, highlighted in yellow, is how can you describe the association of two data sets? We've already looked a little bit at this in the first lesson with positive and negative associations. One new piece of vocabulary for this lesson is a trend line. A trend line is a line that passes through the middle of the plotted points, so it shows the trend of the data. In example 1, we are looking at linear associations. Georgia and her classmates are measuring their height and arm span. They record their data in a table, so how tall they are, and then when you spread your arms out wide, how wide they can do that. How can they determine what relationship, if any, exists between the two sets of data measurements? Well, we know that to determine a relationship, we can make a scatter plot. So we'll plot the data points in a graph like this, and we can already start to see some type of trend. But because we are looking at linear information, or it looks like it's making a line, we can use our pencil and lie our pencil on the graph to see what the trend is. As you can see from this picture, if we lie our pencil on the graph, many of the points are the same distance from that trend line. That tells us that this is a pretty good approximation of what a line through this data would look like. Now, when we actually put that line in instead of using a pencil, we can look at the slope. Here we see that the slope would be positive. Georgia can draw a trend line on the scatter plot to determine that there is a positive relationship between height and arm span. So this new idea of using a trend line, or a line that actually represents the trend of the data. You try. Georgia and her classmates also measured their foot length. Use a pencil to find the trend line. Sketch the trend line for the scatter plot. So use your pencil to try and figure out where a good spot between the data is. Once you decide on a good spot, draw that in. Pause the video, try this now, and press play to see a good answer. Here is my sketch of a line that would go through this data. If yours is similar to this, as long as it's not super different, it should be a good example as well. We're not looking for exact answers, but it should look similar to mine. All right, in example 2, we're going to talk about the strength of linear associations. Some are very strong and some are weak. So the Johannessons own an ice cream shop near the beach. The scatter plot shows their sales by daily high temperature. They compare their sales by daily high temperature to the number of beachgoers by daily high temperature. We're going to describe the association. So here we can see their ice cream sales. Their sales go up as the temperature gets warmer. And here's our beach visitors. As the temperature gets warmer, we also see our number of people is going up or increasing. We do see an outlier in this data. There was a 90-some degree day where less than the expected amount ended up going to the beach. And these both make sense. As it gets hotter, more people want ice cream and more people go to the beach. All right, so both of these have a positive association. As the temperature increases, ice cream sales increase. So this association is positive. However, when we look at the trend line and we look at and compare it to the points, we notice that some of the points are farther away from the trend line. This shows a weak association. So while there is an association, it's not a very significant one. However, when we look at the beach visitors and we notice again that temperatures increase, the number of beachgoers also increases, this association is positive. But with this one, we see that nearly all of the points are really close, almost touching the trend line. So this shows a strong association, which means that our data is going to align with, and it's going to be easier to make predictions better with the beach visitors with a strong association than with the ice cream sales. Okay, so again, the line is kind of like what we would expect, but you can see, you know, when it's hitting 100 degrees, we could have people doing lots of ice cream or not as much. Whereas if it's a 100-degree day, it's almost certain that it's going to stick with our trend line because it's so strongly associated. And finally, we want to also be able to recognize when scatter plots show nonlinear associations. So here we can see something with time and height. We don't know exactly what, but we are seeing all of these points, and we do see it seems to make a pattern, but that pattern is not a straight line. So in this situation, we would say that the points in the scatter plot form a curve. So the scatter plot is showing a nonlinear association between data. So before we only looked at linear associations, but we could say this wouldn't have no association, there is a pattern. We would just say that it's non-linear. So you try. Here are 3 scatter plots. Identify the association, whether it is linear or nonlinear, positive or negative, and strong or weak. Or if there is no association, state so. Pause the video, give your answers on your notes, and then press play to see my answers. The answers I would give for each of these is that A is a strong, positive, linear relationship. I would say B is a non-linear relationship because it looks like a circle. And C has no association. It doesn't make any pattern that I can see. All right, to summarize, I did give you some fill-in-the-blank summaries so you can make sure you are filling in the missing pieces. So now we have that there are a couple types of association, either linear, nonlinear, or none. If it's linear, this means that a trend line can be drawn through the data, and it's either going to be positive or negative. We also can now talk about the strength of the association. It is strong if the points are clustered close to the trend line, and it's weak if the points are spread further away from the trend line. So we can see a visual example here of a nonlinear association or a linear association, one that has a strong association and one that has a weak association. Your next steps are to turn in your 7.2 notes, complete your 7.2 practice, and take your 7.2 mastery check. Good luck, and I'll see you in the next lesson.